On this video, you will learn F-test. What is F-test? The F-test is another parametric test used to compare the means of two or more groups of independent samples. It is also known as the analysis of variance, or that is the ANOVA. The three kinds of analysis of variance are: we have the one-way analysis of variance, two-way analysis of variance, and the three-way analysis of variance. The F-test is the analysis of variance. This is used in comparing the means of two or more independent groups. One-way ANOVA is used when two variables are involved, the column and the row. The researcher is interested to know if there are significant differences between and among columns and rows. This is also used in looking at the interaction effect between the variables being analyzed. Why do we use the F-test? We use the F-test because we want to find out if there is a significant difference between and among the means of the two or more independent groups. How do we use F-test? To get the F computed value, the following computations should be done. First is to compute the correction factor. That is, CF is equal to GT, which is the grand total, squared divided by N. Next is the TSS, or that is the total sum of squares minus the CF. So that is TSS is equal to the summation of x squared minus CF. Next is the BSS, or the between sum of squares. So BSS is equal to the summation of x squared divided by n minus CF. Next is the WSS, or that is the within sum of squares. It is the difference between the TSS minus the BSS. Then, after getting the TSS, BSS, and WSS, the ANOVA table should be constructed. We have here the ANOVA table. So we have the sources of variance, the degrees of freedom, the sum of squares, the mean squares, and the F value, which is subdivided into two, which are the computed and the tabular. Under between groups, in order to get for the degrees of freedom, that is k minus 1, where k is the total number of groups. Then for the sum of squares, that is the between sum of squares, or BSS. For the mean squares, that is the between sum of squares divided by the degrees of freedom between groups. Then, for the within groups, for the degrees of freedom, that is the quantity n minus 1 minus the quantity k minus 1, where n is the total sample size and k is the number of groups. For the sum of squares, that is the within sum of squares. Then for the mean squares, that is the within sum of squares divided by the degrees of freedom within group. Then for the total, the degrees of freedom is equal to n minus 1. Or you can just add the degrees of freedom under between group and within group. For the sum of squares, that is TSS, or the total sum of squares. Then, for the F value, for the computed value, so F computed value is equal to the mean squares between divided by the mean squares within. Then for the tabular value, so we need to look for the F table at 0.05 level of significance. For example, a pharmacy is selling 4 brands of vitamin C. The owner is interested if there is a significant difference in the average sales of the 4 brands of vitamin C for 1 week. The following data are recorded. So we have brands A, B, C, and D. Under brand A, we have 7 data. Under brand B, we also have 7. Under brand C, 7 also. And brand D is 7 as well. Perform the analysis of variance and test the hypothesis at 0.05 level of significance that the average sales of 4 brands of vitamin C are equal. So solving now by stepwise method, first is to identify the problem. The problem is there a significant difference in the average sales of 4 brands of vitamin C? The next is to formulate the hypothesis. For the null hypothesis, there is no significant difference in the average sales of the 4 brands of vitamin C. Then, for the alternative hypothesis, there is a significant difference in the average sales of the 4 brands of vitamin C. Next is the level of significance. So for our alpha, that is equal to 0.05. Next is the degrees of freedom between groups. So that is k minus 1. So we have 4 groups. So therefore that is 4 minus 1, which is equal to 3. Then for the degrees of freedom within groups, that is equal to the quantity n minus 1 minus the quantity k minus 1. So all in all, we have a total sample size of 28. 7 for group 1 or brand A, 7 for brand B, 7 for brand C, and another 7 for brand D. So that is 28 minus 1 minus 4 minus 1. Therefore, that is now equal to 27 minus 3, which is equal to 24. Next is the F tabular value at 0.05 level of significance. So we'll be needing the F table. So we have here the F table for 0.05 level of significance. So on the numerator degrees, that is the degrees of freedom between. So our degrees of freedom between is equal to 3. So locate 3 on the numerator. Then on the leftmost column, that is the degrees of freedom within. So we have computed 24 for the within degrees of freedom. So let us also locate 24. Then, get the intersection of 3 and 24. So their intersection is 3.01. Therefore, the F tabular value at 0.05 level of significance is equal to 3.01. Next is the statistics. So we'll be using the F-test one-way analysis of variance. So we have here the data a while back. So let A be x sub 1, brand B be x sub 2, brand C will be x sub 3, and brand D will be x sub 4. So for brand A, let us first get the x sub 1 squared, meaning to say, we will square all the data under brand A. So that is 7 squared, which is 49, 3 squared, which is 9, 5 squared, which is 25, and so on. So repeat the process on brand B. So we'll be getting x sub 2 is squared. So that is 9 squared, which is equal to 81, 8 squared, which is 64, another 8 squared, which is also 64, and so on. And applying the same process on brand C, that is x sub 3 squared, so we square all the data under brand C, that will be 2 squared, which is 4, 3 squared, which is 9, 4 squared is 16, and so on. And for the last group, that is x sub 4 is squared. So that will be 4 squared, which is 16, 5 squared, which is 25, 7 squared, which is 49, and so on. Next is to get the summation of x and the mean of the groups. First, let us have the brand A. So for the summation of x sub 1, that is 37. So that is the sum of all the data under x sub 1. So that is 7 plus 3 plus 5 plus 6 plus 9 plus 4 plus 3. And n sub 1 is the sample size for group A. So we have 7 data, therefore 7 is our n. Then for the x sub 1 bar, or the mean of group A or brand A, that is 37 divided by 7, which is equal to 5.28. And next is the summation of x sub 1 squared, or that is the sum of the data under x sub 1 squared. So that is 49 plus 9 plus 25 plus 36 plus 81 plus 16 plus 9, which is equal to 225. Then repeat the same process on the remaining brands. So for brand B, the summation of x sub 2 is equal to 57, n sub 2 is equal to 7. Then the mean of x sub 2 is equal to 57 divided by 7, which is equal to 8.14. Then for the summation of x sub 2 squared, that is equal to 475. The next is for the brand C. So for the summation of x sub 3, that is equal to 26. Then n sub 3, or the sample size, is equal to 7. Then the mean of group 3 is equal to 26 divided by 7, which is equal to 3.71. Then the summation of x sub 3 squared is equal to 110. And for the last group, the summation of x sub 4 is equal to 36. Then the sample size is equal to 7. So the mean now is equal to 36 divided by 7, which is equal to 5.14. And for the summation of x sub 4 squared, that is equal to 204. So we are now ready to solve for the CF, or the correction factor. So the correction factor is equal to the summation of x sub 1 plus the summation of x sub 2 plus the summation of x sub 3 plus the summation of x sub 4, then square it, divided by n sub 1 plus n sub 2 plus n sub 3 plus n sub 4. So for the summation of x sub 1, that is 37, the summation of x sub 2 is 57, the summation of x sub 3 is 26, and the summation of x sub 4 is equal to 36. And for n sub 1, n sub 2, and n sub 3, n sub 3 and n sub 4 is equal to 7. So they are all equal to 7. So plugging now these values into the formula, that is now CF is equal to the quantity 37 plus 57 plus 26 plus 36 squared divided by 7 plus 7 plus 7 plus 7. So simplify it further. That is 156 squared divided by 28. So the correction factor is equal to 869.14. Next will be the total sum of squares. So TSS is equal to the summation of x sub 1 squared plus the summation of x sub 2 squared plus the summation of x sub 3 squared plus the summation of x sub 4 squared minus the correction factor, which is the CF. So for the summation of x sub 1 squared, that is equal to 225. The summation of x sub 2 squared, that is 475. The summation of x sub 3 squared is equal to 110. Summation of x sub 4 squared is equal to 204. And the correction factor is equal to 869.14. Then plug these values into the formula. So that is now TSS is equal to 225 plus 475 plus 110 plus 204 minus 869.14. So simplify further. TSS now is equal to 1014 minus 869.14. And that is equal to 144.86. Next will be the between sum of squares. So between sum of squares, or BSS, is equal to the summation of x sub 1 squared divided by n sub 1 plus the summation of x sub 2 squared divided by n sub 2 plus the summation of x sub 3 squared divided by n sub 3 plus the summation of x sub 4 squared divided by n sub 4 minus the correction factor. So for the summation of x sub 1, that is 37, summation of x sub 2 is 57, summation of x sub 3 is 26, summation of x sub 4 is 36, and the correction factor is equal to 869.14. So substitute these values from the formula. So that is now 37 squared divided by 7 plus 57 squared divided by 7 plus 26 squared divided by 7 plus 36 squared divided by 7 minus 869.14. So simplify further. That is 195.57 plus 464.14 plus 96.57 plus 185.14 minus 869.14. So that is now 941.42 minus 869.14, which is equal to 72.28. And next is the within sum of squares, or WSS, that is equal to TSS minus BSS. So the TSS is equal to 144.86, BSS is equal to 72.28. So plug those values into the formula. WSS now is equal to 144.86 minus 72.28, which is equal to 72.58. So we already have computed for the CF, TSS, BSS, and WSS. So it's now time for us to fill in the ANOVA table. So let us first fill in the degrees of freedom. So for the between groups, that is k minus 1, which is 4 minus 1, is equal to 3. Then for the within group, that is the quantity n minus 1 minus the quantity k minus 1, that is equal to the quantity 28 minus 1 minus the quantity 4 minus 1, which is equal to 24. And for the total, that is n minus 1, which is equal to 28 minus 1, is equal to 27. Or you can just add the degrees of freedom of between groups and the within group. So that is 3 plus 24, which is equal to 27. Next is the sum of squares. So for the between groups, that is the BSS, which is 72.28. For the within groups, that is the WSS, which is 72.58. And for the total, that is the TSS, or that is 144.86. Next is the mean squares for the between groups. That is the between sum of squares divided by the degrees of freedom between groups. So that is 72.28 divided by 3, which is equal to 24.09. Then, for the mean squares within group, that is the sum of squares within group divided by the degrees of freedom within group. So that is 72.58 divided by 24, which is equal to 3.02. Then, the last one is the F computed value. So that is F is equal to the mean squares within, mean squares between divided by the mean squares within. So that is 24.09 divided by 3.02, which is equal to 7.98. And for the tabular value, that is 3.01. So after completing the analysis of variance table, it's now time for us for the decision rule. If the F computed value is greater than the F tabular value, this confirm HO. So basing from the F computed value and F tabular value, the F computed value is equal to 7.98 and the F tabular value is 3.01. So our F computed value is greater than the F tabular value. Therefore, we will disconfirm the null hypothesis. Then, it's time for us to make the conclusion. Since the F computed value of 7.98 is greater than the F tabular value of 3.01 at 0.05 level of significance with 3 and 24 degrees of freedom, the null hypothesis is disconfirmed in favor of the research hypothesis, which means that there is a significant difference in the average sales of the 4 brands of vitamin C. So that is the F-test one-way analysis of variance. Thank you for watching, and I hope you have learned something.